Welcome back, everybody. Dr. Greg Eckel, What the Health, the Doctor's Chat. Today's topic is a genetics update, the most important genes for longevity, with a brain health specific conversation with Dr. Sam Shay, who solves health puzzles for busy, health conscious moms and mompreneurs to help them optimize their wellness, longevity, and skin health through unique genetic testing. He's known as the friendly lab nerd. Dr. Shay, genetics analysis and functional testing for data-driven results. Dr. Shay is also a stand-up comic, uses clean observational comedy to educate and entertain. Welcome aboard, Dr. Shay.
Thank you, Dr. Greg. It's good to be here. And just to kind of widen the circle for people, I also really enjoy helping entrepreneurs in general. And I also have a special place in my heart for adults who are on the spectrum. In fact, my first 1 hour at the time of this recording, I'm going to be doing my first 1 hour comedy special in 2 weeks, live here and in Denver. And it's going to be it's called Neurospicy: Love, Life, and Comedy on the Spectrum, and it's edutainment. It's about what it's like to be on the spectrum.
Awesome. Oh man, thank you for sharing that. That's awesome. We'll weave some of that into our conversation today, I hope.
You kind of did already. The likable lab nerd is kind of a little is just grazing the surface of that little topic. Yeah.
Putting it over there. That's awesome. That takes a special being a stand-up comic and going out on that tightrope. I'm excited for you. You got to keep us on the loop on that. There's a lot of discussion on genetics, and I'm wondering if you give a broad overview on, your approach with utilizing genetics. And I mean, are we destined by our genes, Dr. Shay? Is this like, because I have the genes, I'm now forever doomed? How do you talk just generally about genetics with your patients and your followers?
Sure. Genetics is the intersection. Genetics is the great filter through which you put all the internal and external inputs through your body that then ultimately expresses in a biochemical reality. So the genes are, you have all these inputs, whether from the environment or inside, whether it's thoughts, whether it's physical structure, whether it's chemistry, they can get filtered through your genetics and out pops the results. And so are your genes destiny? In part, but not in full. And the best way to understand genes is a dial, and that people have different beginning and end points. Like their dial, their range is either narrower or wider, or biased this way or this way or out this way or whatever it is. Everyone's got hundreds of different dials that are individualized to them, even though we all share the same. We share the same dials. We just the ranges and to which they're tilted varies within each individual. So there are upper and lower limits to how genes can express, and each gene itself is an instrument amidst this big symphony of the rest of the genes. We've got 25,000, 30,000 genes, and the issue that people run into is this overwhelm of, well, there's so many genes, and I run a genetics test and I'm sent this list of 300 health tips, and they're not prioritized, they're not organized. I mean, they may be organized by category, but they're not prioritized by urgency. And ultimately, people leave feeling overwhelmed, confused, and ultimately defeated. And it can lead into this really bizarre nihilistic fatalism around one's health. And I don't, if one is living in some sort of weird nihilistic fatalism about one's health, I think knowing your gene test is the least of your problems. So there's some other things afoot that have to be dealt with. And my frustration with genetics is people ultimately have been feeling disempowered by running genetics testing, where like I said, they're afraid, they're overwhelmed, they're intimidated, or they give up. And that is not what either of us want for anyone running genetics at all. And the way that I approach genetics is, how can we every step of the way make people feel empowered with things that are easy to understand, easy to implement, and easy to see shifts in how their health expresses, and to know with confidence that they're doing the highest priority things for their genes. Because I'm not sure people have actually really seen genetics prioritized.
Right.
They've seen it, explained sometimes with way too much data, but they've never seen it prioritized. And if your focus is to help people live way longer than even the perceived upper limit of 120 years, then there's got to be prioritization. I mean, there is no way around that. I mean, if what the health is, you can rename it to like how to prioritize your health. I mean, it's not a sexy name, not how to prioritize your health so you can live to 150. It's a bit too polysyllabic, but I think we're in agreement on that. Like, you need to
Yeah.
prioritize what to do. So genetics can be an absolutely amazing tool for that. Otherwise, people can just get so like overwhelmed with things that it's not going to be useful.
Yeah. So true. So in general, I mean, we had the kind of the subset title for this, the most important genes for longevity, lowering inflammation, mopping up free radicals in the mitochondria, identifying your genetically optimal diet, and your genetic food triggers. We can gather all of that from genetic testing. And my goal is that you help us prioritize, like, which ones are the bigger ones that we need to be paying attention to. Obviously, they're all important, but like you're saying, you need to prioritize what levers this individual in front of you is paying attention to. While it's always interesting, like, most people know, does your pee smell if you eat asparagus, right? That, so you don't necessarily have to test on the genetic front on that, right?
I didn't realize we were going to bring in some sort of scatological analysis of genetics, but go on. All right.
Well, so I'm wondering.
Way to build the stage here of the topic there, Doc. Yeah, but you go on.
Yes, yes, just to butcher it. The four primary criteria, how do you prioritize, or when you're picking genes for longevity and
Sure.
optimal health? Let's start there.
Sure. So let me, I'll share a slide. And for people who are just listening, and you don't need to see the slide, but for the people visual learners, the slide will help. So what we're looking at here are the four criteria to know what the highest priority genes are. Okay. So if we've got 25 to 30,000 genes, how do we know what genes to look at? So this is like the big picture. So you first look at, of these tens of thousands of genes, which of the genes are looking at the drivers of all diseases, not individual diseases themselves. So I'm not looking at genes for cancer, heart disease, Alzheimer's, stroke, diabetes. I'm not looking for those genes. I'm looking at the drivers of diseases. Those drivers are inflammation, free radical scavenging in the mitochondria, liver detox, vitamin D utilization, not synthesis, utilization. I'm talking about VDR genes for the nerds out there, vitamin D receptor genes. The methylation genes, of which there are easily 12.5 major ones, not just MTHFR. The cardiovascular circulation genes, and then fat energy metabolism genes. There's about 16 of those. And so we look at, I'm kind of jumping ahead, but the 7 categories: inflammation, free radical, liver detox, vitamin D, methylation, cardiovascular circulation, and fat energy metabolism. So then we've got, thousands and thousands of genes are pushed off the table because they're not involved with those 7 drivers. Then we take all of the genes that are within those category, the 7 drivers. Now we got to look at upstream, which of those are the most important. So there are hundreds of genes that are related directly or indirectly to inflammation, hundreds. Which do you look at? Well, I want to look at the top 15 that control the hundreds underneath it. So I want to look at the generals that are commanding the foot soldiers. That's the second criteria. So now we've pushed off even more genes off the table of the 25 to 30,000. Then, of the ones that are remaining, that are of the 7 drivers that are upstream, which of those genes have at least 10% variations in the population? So there are some genes that are, 0.001%, which matter a lot to the 0.001%, but
Right.
they're very hard to find. You need basically a PhD in that gene, special labs, etc. It's not useful for the broad public to run just a genetics test. You really want to search for genes you're likely to find something. So then you, and again, not to negate the importance of the 0.01 whatever percent to the person who has that, but I'm not looking for that. I'm looking for the big stuff. So
Yeah.
then push off all those genes off the table. Then the last criteria, arguably one of the most important criteria, is which of the genes that are left have peer-reviewed research done on humans, not wombats, nematodes, or whatever, that show that lifestyle and diet alone shift the epigenetic expression of the gene towards a positive result. So that's how you whittle down the number of genes to, do you want to guess the number of total genes this is?
This is 18.
150 or so.
Okay.
150. The
Wow.
18, the 16 I mentioned was just in the fat and energy metabolism.
Okay,
There's
got
there's 15 inflammation, 3 for mitochondria, 8 for liver detox, 2 vitamin D receptors, 12 for methylation, but there's actually 3 more you borrow from the liver detox because GCLC, GST, we'll not get too nerdy. Maybe I failed already, whatever.
it.
Et cetera, et cetera, et cetera. So there's about 150 genes that influence that are the most important for influencing health, well-being, longevity, diet, and including now like there's also now in that 150 is now including ones on identifying your optimal exercise, recovery, and fertility.
Mm.
So, and I just want to point out on the slide here, I'll just describe for people just listening. I have an image of a traffic light with cones of light all overlapping. So you've got a red cone of light coming out of the red light, a yellow coming out of the yellow, the green coming, and they're all kind of overlapping in part. And the reason I put that image together is that it's explaining what epigenetics actually is. So if someone has a red dot, like you've got two bad copies, a bad copy from mom, bad copy from dad, for say like an inflammatory gene. Okay, bummer. So what epigenetics is that your starting line is way back from other people, but with really good, solid lifestyle that is consistent, good lifestyle, diet, nutrition, your red gene can express to behave more green-like. It will never be a green dot. Never, ever, ever. Unless you're dumb enough to inject CRISPR into your bicep, don't do it. Look on Google Images. Once you see what happens to this dude who injected into his, like, you'll never do it. It's madness.
Yeah.
You can change how your red dots will behave more green-like. They will never be green. The inverse is that your green dots, if you got a great deal, you got a great dice roll, you run the genetic lottery, whatever. If you have a consistently bad lifestyle, diet, nutrition, your green dot will behave more red-like. And so that's what epigenetics is that if you win the genetic lottery or you lost the genetic lottery, you have a real measure of control with some upper and lower limits. And that's how this is empowering. And I'll give you a very real example. When I got my genetics back, I literally sat and cried for an hour because I was very sick as a child and I was getting ill. Like other people were fine. And I didn't understand why I was so sick and why I was so fragile and frail. And it's just all these weird things that were happening. And when I saw my genetics was so bad. And I was only dethroned 2 summers ago from having the worst genetics of the hundreds and hundreds and hundreds of panels I've run. I'm now silver medalist in the crappy gene Olympics. I used to be gold medalist, but I got dethroned. But the reason why I'm sharing this is that when I saw my genetic report and I cried for 2 reasons. One, I had answers as to why I was so unwell. And 2, I had answers as to what to do because now I had a roadmap of here are the underlying genetic mechanisms that I can now target specifically to drive the sea of red and yellow dots to behave more green. So that's where genetics is very important. As a practical example, I was in joint pain like an 80-year-old man in my 30s when I got my genetics back, and I didn't understand why. And it turned out I'm a hyperinflamer. And
Mm.
my inflammation happens to show up in pain in my joints and other things like quick to anger, skin rashes, severe insomnia. But the inflammation for me showed up in those particular ways. Within a month of changing my diet, my diet and lifestyle nutrition specific to the swath of pro-inflammatory genes, my joint pain went away. So
Mm.
it's these are non-trivial changes that can happen. And it was information I could not get from functional tests. I couldn't get this from a mitochondria panel. I couldn't get this from an adrenal. Not that I don't love those. I teach and run those all the time. They're great. I teach on I helped design the Nutristat test out in Australia, which is now here in the States, which is the latest, big 240 whatever odd marker test for mitochondria. Great test. It's a different window into one's health. Ideally you need both. The genetics will tell you how do you live, where are you aiming to live optimally, and what are the genetic fault lines that you've inherited that you have to shore up. Whereas the functional tests like mitochondria, hormones, gut testing, other blood tests, etc., they're a thumbprint into what is going on in your physiology now, right now. The genetics don't tell you what you got going on now. They don't tell you what gut infections you have. They don't tell you the state of your mitochondria now. They don't tell you what amino acids you got or don't got now. They don't tell you your hormone levels out. They tell you the probabilities and trajectories. But the thumbprints don't tell you they don't tell you the big long-term permanent trajectories. So you ideally both, but what I think most people are missing is a foundational genetics analysis to tell them how they're to live optimally and where their fault lines are that they've got to shore up, because if you don't shore them up, they're going to show up. I should probably
Mm.
write that down. If you don't shore them up, all right. I'll try not to dislocate my own shoulder, patting myself on my own back for that little phrasing.
That was a good one.
Thank you. Thank you. Thank
Yeah.
you. I'll hear all night. All right.
So I mean that's a phenomenal way of describing that, and I really appreciate your enthusiasm on it too. So if we get into the weeds then on this, you brought up inflammation and your inflammatory markers, what are the most important genes in inflammation? And I think
Sure.
you're tying this to free radical damage scavenging and vitamin D utilization. And
So here's an example of the 50. Here's the 15 inflammatory genes. Now, for people who are, and I'll read them off for the people who just listening. Well,
And
no,
we can get
all of them.
geeky. Our listeners and viewers
Okay.
like the geekiness.
All right.
Well,
Challenge
yeah.
accepted. Okay. All right. Here we go. So what you're looking at here are the 15 most important pro-inflammatory genes, and I broke them up into three parts. And inflammation initiation, inflammation propagation or sustaining, like they just keep going, and then there's people who have trouble extinguishing or clearing the inflammation. So there's three, and the genes that are responsible for initiation are the interleukin 1s, and there's interleukin 1 alpha 1, interleukin 1 alpha 2, interleukin 1 alpha beta, interleukin 6, and TNF alpha. Those are the big ones for initiation. Then there's the genes for sustaining the inflammation. That's interleukin 8, interleukin 18, the three CRP genes, CRP 1, 2, and 3, and COX-2-3 and COX-2-4. Now, again, I just want to remind people, for the super extra special genetic nerds out there who may be screaming into the mic right now, like, wait a minute, what about this? What about this? Like, remember, the four criteria are, again, do they control the driver? Are they upstream? Do they have variations at least 10%? And do they have peer-reviewed research done on humans to show the lifestyle and diet, nutrition, etc. alone will shift the red dots and yellow dots into green-like behavior? There's hundreds of genes, hundreds, that are involved directly and indirectly. These are just the ones that fulfilled those four criteria. So I'm not negating the presence of other important pro-inflammatory genes. So those are the ones for sustaining, and then the three for clearing, which I personally believe are the three most important of the 15, are the interleukin 10s Because if you've got a small fire going, and if you only got a squirt gun and no fire hose to put it out, and it just keeps burning, 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 you're going to have a problem no matter what.
Yeah.
So these are the 15 most important genes. And what I've seen, this is taken from this is a sample from an actual client of mine. In her case, what happened was that she joined a CrossFit gym without telling me.
Mm.
And the CrossFit, we'll call him a trainer. I call him an enthusiastic training cultist. Had her exercise an hour a day for like 5-6 days a week. And what happened is that she got fatter
Mm.
and her cycles went off. And in fact, because of this, I made a presentation at a genetics conference called Exercise-Induced Obesity. Exercise-Induced Obesity. And what happened was that, I mean, talk about a mind trip. What happened was that she was so pro-inflammatory, and I circled the dots here for the people who are watching this. In all three categories, she had trouble with initiation, she over-sustained, she under-cleared. Is that for people who are really pro-inflammatory, and the inflammatory chemicals from over-exercise, first off, their bar from healthy exercise to over-exercise is lowered way down, so they can trip into that over-exercise much quicker. What happens is that inflammatory chemicals are very damaging to cells and tissues. So what happens is that the body will retain water, interstitial water, to dilute the inflammatory chemicals from hitting the cells and tissues. So the weight she was putting on was not caloric. It wasn't calorie weight. It was puffy inflammatory water weight. It was water weight, because the body was retaining water to dilute the inflammatory chemicals to do what? To buy the liver and kidneys time to get rid of them. So the more she exercised, and this becomes this positive feedback, or that's a downward spiral rather. Oh, the exercise, oh my God, I'm not losing weight, I'm putting on belt. Better exercise more. Oh, I'm still putting on weight. Oh, better exercise more. And it becomes this vicious cycle. So she called me in a panic and said, I don't know what's happening. My cycle is off. I'm getting fatter. I'm doing all this exercise. I feel worse. And I had a few choice words for the trainer, but I censored myself to the best of my ability. And then looked at her genes. It's like, look, you're massively pro-inflammatory. Plus, when we look at your 8 genes for liver detox, I'm just showing this for the people who are just listening. There's 8 major genes for liver detox. 3 for phase 1, 5 for phase 2 detox. She had 4 variations, 3 of which were directly related to estrogen metabolism. The other was related to inflammation and free radicals. And if you look back she has very particular clusterings here back in the inflammatory genes of the CRP. CRP genes are responsible for the genes for the acute inflammatory phase protein in the liver. So that's really important detail, because if your liver is responsible for detoxing hormones, remember, she got fatter and she stopped cycling. Her cycle went super wonky. What happened was that she got overinflamed. She had a particular genetic weakness to have extra inflammation in the liver, and she had problems with detoxing estrogen in her liver anyway. So when she got super inflamed, her liver had to choose between dealing with inflammation, which there was an extra dose of, or dealing with estrogen. So we'll put it in much more simple terms. If you walk into your kitchen and you have to choose between throwing out the garbage or putting out a kitchen fire, what's the priority?
Right.
The stove is on fire. You're going to let the garbage sit for a little bit, right?
Yeah.
So it's the same thing. If the liver is inflamed, it cannot and will not do detox. It just won't do it. It's got other problems. So that's why her cycle went off. Now, for men, I saw this happen in men, the same thing, exercise-induced obesity, happened slightly differently. Similar pattern of inflammatory and liver detox. I did a presentation on this in the genetics conference on this. The difference was that men obviously don't have cycles to stop, but they developed man boobs.
Yeah.
Because the estrogen buildup repositioned the inflammatory fat weight on their chest.
Yeah.
So that, and then for them, the answer was similar to what it helped her out with, was anti-inflammatory, liver detox, clean diet, reduce the exercise down to at most twice safe high intensity interval training a week with at least 2 days buffer in between, followed by anti-inflammatory things like whether it's sauna or massage or lots of walking, sleep, tons of water. I identified the exogenous sources of estrogen that, especially for these guys, whether it was like heated plastics or sprayed vegetables from the Dirty Dozen from Environmental Working Group, or like there's that's a whole separate discussion of exogenous sources of estrogen. But we
Right.
just reduce the estrogen, got them on the anti-inflammatory liver supporting diet, got them on anti-inflammatory liver supporting nutrients, reduced down the exercise, increased recovery protocols. One guy lost 40 pounds in 1 month. The other
Wow.
guy lost 4 pounds a week for 12 or 13 weeks. I can't remember. He's just slow and consistent. And it came off the chest, it came off the belly. And it was big. Everyone else was telling him, you got to diet more and exercise harder, which is
Oh,
exactly the wrong thing to do for him genetically.
that would be so frustrating for all of those patients.
Demoralizing.
Yeah,
Demoralizing.
and
Yeah.
we've seen it, like they're just probably just imploding on themselves, like I'm not good enough. They're telling I got to do it more. And I've seen those folks too. It's so frustrating. So it's really nice to look at this as their platform.
Mhm.
The way that I talk about it is you get to move to the front of the classroom because now we can understand your what we're playing with here for you, because you're uniquely you with regards to this. So that would have never been found, Dr. Shay, had you not looked at it and discovered that. That's awesome.
Yeah, and this is the power of looking at the highest priority genes. That
Yeah.
that's that's the meta message here is what's the highest priority? And if we know where to look, then we know how to take action. And the actions I took were, if you've got 15, pro-inflammatory genes plus liver genes and other ones that are also involved, like vitamin D receptors and so on. I don't give 15 separate recommendations for 15 separate genes. The way you prioritize is you find which of those 15 genes you have a lifestyle intervention, and then you find how many of the genes is beneficially affected by the same lifestyle intervention, again, in a peer-reviewed study done on humans. That way, so if I have one intervention that helps 10 out of the 15 pro-inflammatory genes, well, guess what I'm going to recommend first?
Yeah.
So so now I prioritize a list of, here are the lifestyle interventions that will affect the most number of the highest priority gene variants that you individually have. So here's your list. There's like 30 of them, but you don't start with all 30. Here's the top 10 by the numbers, because I list out exactly how many genes are beneficially affected based on the peer-reviewed research. So you know exactly which things to implement first, next, and last. So you have full confidence. Even if you just do 3 things, you're doing the top 3. I can
Yeah.
absolutely guarantee that. You're doing the top 3 based on the
That's
science.
awesome. So, and you have your own platform that you're running the genetic analysis so that you've got it sorted and parsed, and of those
Absolutely.
50. Could people utilize, let's say they had raw data or from another company, or it's just easy enough to get it through your
Sort of. So if people have the 23andMe or Ancestry, and it's not too old, like it's at least 2017, possibly earlier, but the earlier you go back, they may be missing some of the higher priority genes, but even then, those are still available. I mean, I was doing this back starting in 2016. So, because there's newer stuff that's come out. But like 2017, 18 is kind of like the cutoff for getting almost every single one of the highest priority ones. The That will give you the vast majority of the reports and data that I need. It will not do the gene test to identify if you're keto, paleo, Mediterranean, or high carb. That's a very, very different, that's a completely different analysis. It's a completely different, I'll just pull up a picture. It's a different swab. It's a different analysis. It's a different there's a three-dimensionality to genetics that people don't understand or much less talk about or can do something about.
Yeah.
So we're talking now about copy number analysis, not variation analysis. So variation analysis is what most people understand. Is it a green, yellow, or red dot? You know, that's what most people understand. That's what we were talking about before. I'm not
Yeah.
talking about that now. What I'm talking about is the number of duplicates between the start and stop codon. That is the number of duplicates of the gene. So, and specifically, it's the gene that creates the enzyme amylase in the saliva to break down carbs. So if the more duplicates you have, the more carbs you can tolerate. The best analogy I could think of is imagine a fort, a medieval fort, and the Visigoths or the Vikings, they're charging the fort, and you've got a certain number of cannons on lining the wall of the fort. And for sake of numbers, say you can fire 100 things per minute. Now it's a super fast cannon. Obviously, that never happened, but you just for ease of numbers, people can
Sure.
keep track of it. It's call it 100. We'll tell Dan Carlin we got our historicity wrong. I don't know if you know that joke, entire core history joke. Anyway, it doesn't matter. If for the people who want a really great podcast, possibly the best podcast ever recorded in all history, it's called Hardcore History by Dan Carlin. It is mind blowing. Particularly listen to the ones on World War I. I've listened to them 3 times. It will explain literally everything that's happening right now. So, okay, sidebar. So imagine you have a fort and you got a wall and you got cannons. So if I have a cannon, the version of the cannon is the green, yellow, red dot. Does the version of the cannons pump out 100 bullets, 95, or 90? Because in this case, this gene, the difference between green, yellow, and red is so small, it's actually negligent. The variation actually doesn't matter because it affects how many bullets fly out, but they're so close together, it doesn't matter. What does matter is the number of cannons. So if I had 1 green cannon for 100 bullets, or if I have 7 red cannons at 90 bullets each, what would you rather have?
Yeah.
You know, so the number of cannons matters way more than the variation. So what you're looking at is a range of 1 cannon to 20. There's been very rare cases of an over 20, extremely rare, but 1 to 20 cannons. So people who have a low copy number, a low carb number, as we call it, they are the keto. I actually split them out here. So like the people who are 1s to 4s are the ketos to paleos, the 5 to 8s are more the Mediterraneans, and the 9 pluses are high carbs. Now the shades of gray, because I figured out a system based on the number that you can actually get very, very granular of how many carbs you can have on at a meal. So you also have to account for the size of the individual, because it's like if you get a number, well, if I'm a 6, does that mean it's like 600 calories from carbs a day? Is it 6,000? Is it 600? Is it 60? What is it? Well, this puzzled me because this is a true story. I was watching Game of Thrones, as you do when you're thinking about genetics analysis, as you do.
Yeah.
And I was watching Tyrion, the character Tyrion, who's played by oh my God, what's his name? Oh my God, he's a great actor. He's one of
We know who you're talking
okay,
about.
the dwarf. Okay, so anyway, he's wonderful. I love him. Love this actor. Tyrion, he's actually friends with the Mountain. The guy's named Bjorn or some Viking name or whatever. He's literally the strongest man in the world. Lifted 501 kg. That's over 1,000 pounds. Literally, they're friends in real life. Now, technically, both of them could be a 6 genetically. So how, if I was to tell 600 calories to Tyrion, he could barely eat that. We back?
We are back. Yes.
Okay.
You just paused on he could barely eat that.
He could barely fit between his front teeth, the 600 calories.
Okay.
So I was like, how do I because genetics is genetics, and I can't just hand someone a report saying 6 means this. That's nonsense if you account for the massive differences. So I was really agonizing over this again, watching Game of Thrones, and I remembered, oh, because I used to teach X-ray analysis to chiropractors trying to pass the national board exams, and I'd fly around the country and teach clinical and basic sciences and X-ray. And I was like, oh, wait a minute, dwarves have unique finger bones, and because we taught that in X-ray analysis. So I was like, wait a minute, what scales roughly with height and weight? Finger size.
Yes.
Finger size scales roughly with height and weight. So if I was to give a 6 to Tyrion, it would be 6 fingers.
Hmm.
And to Bjorn, it'd be 6 fingers, because Tyrion's tallest finger is probably 3/4 the length of my pinky, whereas Bjorn's tallest finger is probably 3/4 the length of my forearm.
Yes.
Right?
Yes.
So you see how that scales? Like,
Yeah.
it actually can be individualized. Now, the genetics company, they're scientists, they're not clinicians. Okay, like I'm the clinician. So I
Yeah.
take their science and make it practical. That's what a clinician does, technically. Clinicians
Yeah.
take the science, mix it with our art of practicality so we can win in real life. That's what we do. So once I figured that out, I did a nerdy victory lap like you wouldn't imagine. And
Love it.
so now I have a frame of how to not only figure out if someone is keto, paleo, Mediterranean, or high carb, but to individualize the carb amounts based on the individual person. Now, for me, I was eating a perfect Mediterranean Portlandia 6-number diet where I knew the names of my farmers and their chickens. And I was having terrible gut problems, bloating, energy dives, and all the rest of it. And then I did my genetics test, and I was a 2. I had the second lowest carb tolerance you can have. So
Wow.
within a week of changing my diet, my gut problems disappeared. It wasn't a carb quality issue because I was having all organic, soaked, and
Yeah.
blah, 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 all the perfect stuff. It was a quantity issue. Quantity. I could not genetically handle the amount of carbs. So,
Interesting.
and
I
if I,
love this. I'm really interested. I'm going to talk with you off air of bringing this into our community, our brain regeneration community, and really get this going, because I love that you really hit it with taking the science and putting it in real world experience. And I love that of what you're doing to make this very usable for people, because so many times it's just this data flow and it's like, well, I don't know what the heck to do with all of this information. It could take me years to really get through all of it, but you've got it laid out in usable fashion and what levers to push on when. That is so important, and what is really missing for so many people. So I'm excited. We're gonna have to do a part 2 of this, because we just did the tip of the iceberg here, and I want to dive into some of these veins that you've opened up. And I just super appreciate you bringing this alive for us, Dr. Shay.
absolutely, as you can tell, like, I love sharing this and nerding out and throwing in some comedy slash.
It's awesome. It
Yes,
is awesome.
I do contemplate genetics while watching Game of Thrones. This is welcome to number.
I love that. And I love you even more. How about that?
Thank you.
So I super appreciate you coming on. Folks, if you got something out of the show today, please go out, give us a like, a thumbs up, a 5-star review. Say what you got out of today's show. And I think one of the action items is we want to make your test available to folks to actually get some usable data for them. So I'm going to put all of those links in the show notes, and we're going to have you back on, and we're going to dive even deeper. So thank you, Dr. Shay.
Thank you, Dr. Greg.